Hello, my name is Del Ebright. This is my project pseudocode for the Programming with C project. Now, some of this is going to look a little rough because my pseudocode tends to look more like actual code than at least what this AI showed me. And also, I didn't just do B and D, I did A, B, C, and D. I did all of them. And we will start with the function for matrix addition and subtraction. Operation A, if you will. We start by initializing the matrix A, B, and result matrix along with the rows and columns of A and B, and the user choice for which operation. Then, using this while true and break statement, I am checking the dimensions of the matrix C to make sure they're the same, because for matrix addition and subtraction, the rows and columns of each matrix need to be the same. And then after it checks that, it gets each actual element of both matrix here and here. And then here it asks the user now whether they want to do addition or subtraction. And this is where we do it, where each element of matrix result is created by the sum or difference of matrix A and matrix B. And then it prints it. And then this is operation B, matrix multiplication. We start with the same thing. A lot of these are going to start with matrix initialization here with the rows and columns and result. And then this one's going to check also the dimensions. For multiplication, the dimensions are a little different. Matrix A's columns need to be the same as matrix B's row. And that's just because of the nature of matrix multiplication, where for every column, for everything in a column of A, we were multiplying it by the row of B for every row, or for every row of A and for every column of B. And this is where we do that. And that's why we have these 3 for loops nested in here, is because we're basically multiplying everything together within each other. Like every column is being multiplied by every row for every column in B. And then here we print that result once again, that new matrix. And then here is the transpose operation, operation C. This is the easiest one. It does the same thing. This one is initializing the matrices here, getting the rows and columns, getting the elements, and then in just these 3 lines is when it transposes. And that's basically just flipping the rows and columns, which you can see here, where the I and J of matrix result and matrix A are switched. And then once again we print the function. Here is Kramer's rule, which is what we did for finding solutions of simultaneous linear equations, or operation D. This is basically Kramer's rule and how to find those solutions, and the picture I used for this operation. We start the same way by initializing the matrices, getting the elements, but this time the column and row amount is fixed for A and B, because in order to do this, A needs to be a 3x3 and B needs to be a 1x3. And then we get the elements of A here, we get the elements of B here, and then just like in Kramer's rule, we need the determinant A1 of this matrix here, and 2 and 3. And that's what we do here with this block. And then the next block is when we actually solve that. That determinant A is being solved that matrix is being solved here using cross multiplication and simplification with addition and subtraction throughout this whole complex formula, which I can make a function in the actual code. And then, afterwards it checks if the determinant is 0. If it is 0, then it's a no solution. If it's not 0, then we just take the actual value of the determinant x and the actual value of the determinant a and divide them. And that's what gives us our values for x, y, and z. And they are printed down here. Finally, we have the main function. Here, we are just prompting the user which operation they'd like to do, A, B, C, or D. And here I use if operation equals A, B, C, or D, and then I have the functions being ran themselves, which is different than how the AI did it. The AI is printing many times here and then getting one prompt, and then afterwards it also starts with its main program. I end with mine. The AI starts with its main program, and then afterwards it does like a case switch with the function inside instead of my if else. And then when it comes to using the AI versus my pseudocode, I would say that I'm more likely to use my pseudocode just because it is more similar to what the actual code will look like than the AI. Although I might come back to the AI version because it does look neater, it's more readable, and it is correct. These pseudocodes do output the right thing, and as far as I can tell, it doesn't use anything that we haven't learned outside of class. So if I need just a refresher or to come back, maybe I'll look at this, but for the most part I'll be using my pseudocode here. There was no issue I had with this really. The hardest thing is just getting all of the text in the prompt, because AI will try and answer you immediately. It won't let you send more than one message at once. But other than that, it's pretty good. But I'm probably going to use mine still. Anyways, that was my pseudocode for the project for Program with C.